Hello all, welcome to this online recording sessions in data science. So in this series, we are going to start deep learning applications. Okay, so we are going to see what is deep learning. So how the deep learning concepts will be there in this series. Okay, so let us see one by one. Okay, so see first, let us talk about the introductory part of deep learning. So how deep learning came into picture. So based on what inspiration deep learning has evolved, all we'll talk about this. Okay, so why deep learning came into picture. See if you observe this slide, so you could notice this one diagram. It is a biological neuron. Okay, it is nothing but our brain cell. It is one of the brain cell. So you could see all the parts: dendrites, nucleus, cell body, axon. Okay, so through all these parts the information will be transferred to the cell. Okay, it processes the information and it gives the output. Okay, so from axon it will pass down to the next neuron. So okay, in this process the information will be passed to one cell to another cell in our brain. Okay, so taking these concepts into picture, so we need to design a software based approach. Okay, in this software based approach we need to design a code in such a way that we will be creating a neuron. It will take inputs, process and gives the output. Okay, which will somewhat function like a biological neuron. Okay, we'll design it in a code part. Okay, so this concepts gives an inspiration to design a neurons. Okay, practically with the help of code we'll be designing a neurons like this. Okay, so that is what the deep learning is all about. Okay, so mimicking a human brain cell. Okay, yeah. First, before going to deep learning, okay, concepts, let us talk about why deep learning came into evolve, even though machine learning is there. Okay, so if you observe, there is a one Venn diagram. Okay, so if you take this as AI, okay, this is AI. So in this AI we'll be having data science. Okay, so in this DS we'll having ML. Okay, this is ML. Okay, this is DS, this is AI. Okay, ML. So in this ML we'll be having DL. So in this DL we'll be having NLP, computer vision, and in this subdomain we'll be having generative AI, agent AI, so which are coming. Okay, so which are recently coming. Okay, so see, this is the diagrammatic Venn diagram representation of the overall AI. Okay, so see, if you look into this diagram, ML is there. So inside ML we are studying the deep concepts, deep learning. Okay, so inside ML we'll be having a deep learning. Okay, so why deep learning came into picture, even though we are having many machine learning techniques. Okay, machine learning libraries. So what is the necessary to study deep learning? Means we can see the main points. Okay, so main important points. Okay, so one thing is, the very first point is, we can say there are ML algorithms like linear regression, logistic regression, random forest, decision trees, which work on only numerical data. So okay, so if our data is only in the form of numerical data, okay, numerical data, okay, everything will be numerical, then only we can apply machine learning. Okay, so what if the data is in the form of images, audio, videos? Okay, in that case machine learning fails. Okay, all the machine learning algorithm fails to work on the image data sets. Okay, mostly. Okay, so it doesn't give proper results. Okay, with the help of machine learning. Therefore we need to go to deep learning algorithms. Okay, so that is the reason, if you want to work with image data sets, okay, numerical data full-fledgedly with a better accuracy, then we need to study deep learning. Okay, so machine learning supports only on numerical data. Okay, next, second point. Okay, machine learning involves libraries, right? Some libraries. So what are the libraries that are required for machine learning? We need sklearn. So sklearn has all the things. Okay, so all the algorithms, all the pre-processing, all the EDS steps, all are there in the sklearn algorithm. Okay, apart from this we will be having few more libraries like XGBoost, okay, random forest. Okay, this is all about machine learning. Then whereas coming to deep learning, so what do you have? We have libraries like TensorFlow, Keras and PyTorch. Okay, so TensorFlow, Keras, PyTorch. So if you know these three libraries, you can work on the deep learning. Okay. So TensorFlow is the main library. So on top of TensorFlow, we will be using Keras. Okay. Say suppose if you're learning front end. Okay. How do you study front end? So first we will study HTML, right? So on top of HTML, we will apply CSS, like decorating part. So we'll be decorating the pages that we have designed with the help of CSS, right? So in the similar way, we'll be designing entire algorithms and entire neuron concepts using TensorFlow. So on top of TensorFlow, we'll use Keras to decorate it. Similarly, like this. Okay. 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 These are the three libraries that can be mostly used for studying deep learning concepts. Okay. Next, machine learning only supports small data sets. Okay. Machine learning only supports small data sets. If it's a huge data sets like GB, so 100 GB, so 1.5 GB, okay, 2 GB, 3 GB, 5 GB. So if it is a very large data set, then machine learning fails again. Okay. So then we need to go to again deep learning concepts. Okay. So deep learning supports large data sets. Machine learning supports small data sets only. Okay. Okay. Then how does machine learning models will be saved with the help of .pkl, okay, extension, whereas deep learning models will be saved with .h5 extension. Okay, so these are the main differences which we can know to understand why we need to study the deep learning concepts. Okay, so what are the drawbacks of deep learning? It works on small data sets only. It works on numerical data set only. But whereas deep learning, it works on image data sets, video, audio, okay, data, and as well as it works on large data sets. So that is the key difference. Okay. Yeah. That's the reason we need to study deep learning, right? So what are the different types of deep learning techniques? We can say there are mainly four main different types of deep learning techniques. Okay. 4 types. Okay. So one is ANN, CNN, RNN. Okay, so we have GANs also. We have one more thing also, 5th one, autoencoders. Okay, so these are the 5 concepts that we can that are classified under the deep learning. Okay, types of deep learning. Okay, there are a few more also which are evolving day by day, so which can be added to this also. But out of all the types, these are the main 5 types of deep learning. Okay, so if you look into the each type, we can say ANN, we can use mostly for text data. Okay, CNN we can mostly use it for image data sets. Okay, RNN we can use mostly for sequence data, okay, or time series data. Okay, GANs, okay, so we'll have for proper training, for proper execution purpose, we'll use GANs. Okay, then autoencoders. Okay, so these are another 5 types in the deep learning. Okay, so in this slide you can see the 2 types, CNN and RNN. Okay, so next we can see GANs. So in GANs what we have encoder and decoders. Okay, so encoders will generate the images and decoders will identify the fake images, and again the back propagation comes, and again it keeps on repeating. Okay, the loop keeps on repeating. So generator, discriminator will be there. So generator will be generating images, discriminator will be identifying whether it is real or fake. Okay, so then if it is not appropriate, then again it will be given as a like back propagation. Again so the generator will regenerate the image, again it will give it. Okay, next we'll have autoencoders. These are mostly used for unsupervised learning tasks. Okay, so these are the types of deep learning. Yeah, how do you represent the neuron? Okay, so we, from the inspiration of biological neuron, we understood that we need to design the neurons. Okay, to generate informations, to understand the informations and process it, right? So how does the block diagram or diagrammatic representation look. Okay, so there are two ways in representing the neurons. Okay, so neuron or perceptron, you can call neuron as perceptron also. Okay, yeah. So if you look into the diagrammatic representation, yeah, these are the two different types of representations. Okay, this is SLP, single layer perceptron. This is MLP, multi-layer perceptron. Okay, so we are going to see in detail about this two. Okay, yeah, before that, let us talk about what is neuron or what is perceptron. Okay, perceptron is a basic unit in neural network which mimics the human brain. Okay, so it is the basic cell, okay, which replicates like a human brain cell, where it will take the input, process it, and gives the output. Okay, where it will use some concepts like activation functions. Okay, yeah. So what are the main components to study to build a perceptron or a neuron? Okay, we need input values, weights and biases. Okay, summation and activation function. Okay, so these are the main components of the perceptron. Okay, so we need these concepts to build a neuron. Okay, yeah. So first one, input nodes or input layer. So input layer, what it will takes the inputs. Okay, so what are the inputs here? So you can see like this: x1, x2, x3, and so on up to xn. So these all are inputs, nothing but a features. We can call features also inputs. Okay, so what are these actually? Say suppose if I have an image. Okay, so in this image, say suppose I have a cat image. Okay, so cat image. So in this cat image, you say what are the features here? Eyes, nose, ears, okay, face. Okay, so all these are features. So we'll be taking all these features as a inputs. Okay, so based upon these features only, we will be identifying whether it is a cat or a dog. Okay, if you take dog features also. Okay, so we'll take the features and try to compare the images with these features. If the features are like this, say suppose I'm a human, right? So how you're telling I'm a human? Because I'm having all the features that are similar to the human. Okay, I have eyes, nose, hair. Okay, so all those things are the features. So I have a features that are like a human. So then you can say it is I'm a human, right? So similarly, if you take any image and see all the features, okay, so if the features are similar to that particular image, then we can say it is so and so image. Okay, so like this. Okay, so eyes, ears, nose, okay, all those things are nothing but a inputs, nothing but a features. Okay, so we'll be taking this as a inputs. Okay, next, weights and bias. Okay, so what are the weights and what are biases here? So weights parameter represent the strength of the connection, okay, between units. Okay, okay, so bias, see suppose I'm talking here. Okay, so it is audible to this region only, say suppose some meters. Okay, so if I want to reach my voice to the far off place, okay, say suppose nearly 500 meters up to 1 kilometers, then what I can use? I need to use a bias. Okay, bias like adding speakers. Okay, big speakers I can put it, then I can bias my voice to reach the far of the places. Okay, so in the similar way, so we have used neurons, right? These neurons need to travel far of places. Okay, so from one cell to another cell, it needs to travel different paths. Okay, different paths, different obstacles, and different distances, right, without losing any information, right? So all those will be taking care of the bias. So bias will what? Bias will help us to reach the information perfectly. Okay, it will makes the neuron to reach information correctly and without any loss of information. Okay, yeah. Next, activation functions. Okay, activation functions. See, suppose if the neuron is very weak, will it fire? Will it fire? No, right? So if the weak neurons are there, then there will be less chance of firing. That means it will not pass the information to the other cell. We need some energy, right? So you can see some real life examples also. So at the earlier stage, you could remember everything, right? So what happened yesterday, what happened day before yesterday. So who is my mother, who is father, who is our ancestors, who are our family members. You can remember all the names. But as the time passes, gradually, our memory power also decreases. Okay. So if you observe the neurons, for a normal person, there will be many neurons. Say suppose many. So as the age process, we have only few neurons. We become very old, right? So some cell will be dead. Okay. So that means our at that period only we could see. We may not see the objects clearly. We may not remember the past things clearly. We may not remember some people also clearly. Okay. So all those because neurons got dead. So as we become very, very old, our neurons will be dead and will they start to lose some important information. Okay. So that is the reason. So in the practically also in the code part, when we are designing neurons also, we need activation functions. Okay. So that decides whether the neuron should that makes the neuron to fire the information to other cell or to next nearby cells. Okay. So these are the different components that are needed to design a neuron. So what one is input. Okay. Next one is bias. Next one is activation function. So these are the main components that are required to design an deep learning neuron. Okay. Neuron. Okay. So next, what is the difference between neural network and deep learning? Okay. So neural network is, if you're having less neurons, we can say it is a neural network. Okay. Less neurons or perceptrons. Okay. Deep learning, if there are many neurons, then we can say it has a deep learning concept. Okay. So that's all for this session. So in this next session, we are going to see diagrammatic representations of SLP, MLP. Okay. Single layer perceptron, multi-layer perceptron. So what are the different types of perceptrons or neurons that we have, the difference between them. Okay. Okay. Thank you. Thank you all. Thank you for giving this opportunity.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.